Okay, this is a Precision Matthews 1340 GT lathe. And this is the quick change gearbox right here. It's an open gearbox. So the oil that lubricates this, all these gears and the bearings that are in here, is drip lubrication. And it drips down underneath and pools up in here. It's not a sealed, closed gearbox, it's open. And the way this gets lubricated is there's this piece that came with the lathe in like that, and the cover, the control panel here fastens on like that, and in behind here this cover sits permanently, and there's this little plug here, this little port that you're supposed to squirt oil into, and the oil comes out right here, which will be directed right down here, and all that oil is supposed to make it down here and lubricate these gears and the bearings that are further down the line. And in my opinion, it leaves a lot to be desired. So I'm improving that and making it better. And this is what I came up with. This is a block of aluminum. It started off as 4 inches wide by 9 1/4 inches long and 3/4 inch thick. So I've got 2 galleries I drilled down here with 1/4 inch. These galleries are drilled with a 1/4 inch drill bit that was 12 inches long, and it had 9 1/2 inch flutes. So we got one gallery coming down here and the second gallery coming here. And so this is going to sit in here like so. And then I have my one-shot lubrication pump that I'm going to mount right down here, low enough that I can pour oil into it as needed. And for now, this isn't going to be a permanent solution for the plumbing that I'm going to use, but I just have 532 Danfoss hose or tubing. It's 532 diameter. That's the outside diameter. And these push connect fittings, I've drilled and threaded a 1/8 NPT port. So that's 1/8, 27 threads per inch, national pipe taper. And the push connect side here is for 532 tubing. The pump that I ordered off Amazon is, I'm pretty sure it's a knockoff of a better quality pump that you can get from somewhere for a lot more money. And it came with 4mm threaded tube elbows on it, the outlet ports. It's a dual output pump, and I'll just grab it and show you. Not a good example because my ports are taped up, but you get the idea. They're elbows here, and they're 4mm tubes. So 4mm and 532 is 1/1000th of an inch difference. 532 is 1/1000th of an inch below 4mm, I believe. It's 156 thou, which is 532, and 4mm is 157 thou. So it works. Almost interchangeable. Okay, this angle here, once this cover is installed onto the front of the lathe here, I had to caught here. This is beveled at 78 degrees. So that's the angle of this, the front face of this, of the headstock on the mill is 78 degrees. So I set the milling head on my machine to 12 degrees off of 90 and milled it, and it worked out really nice. And what I did here was this kind of quick and dirty. It wasn't the best way to do it, I suppose, but I didn't want to drill a hole through this casting here and run the wiring for the switches through here. That way I wouldn't have to interfere with the manifold. I'd rather just notch this because this was dead space between the galleries that I drilled. So it wasn't a big deal. Just notch that out, and that cable can come in like this. Everything's harder to do with one hand. There we go. Like that. Well, that's upside down. There. That should work out pretty good. The next step in the next video, I'll have the pump installed and I'll give it a go. And one more thing here. This is cheesecloth, I think. I'm pretty sure it's cheesecloth, and it came with the lathe to protect those ports. And it's a good thing because this rough casting of this piece, this plenum, this oil plenum or whatever you want to call it, that sits in here, it definitely does not seal up tight at the back. And so you can get quite a lot of chips that end up going in behind here in this cavity, and they sit on top of there. So if you're doing anything like this, any modifications, definitely have a means to be able to either seal this up or have a filter of some sort.